function, and then they give you something like this. They're just telling you this limits the domain, which limits the range, which means when you go to graph it, no arrows. Okay, so if we're going back over here, okay, well, technically, if I was graphing this one down the bottom here, and this was it here, I would put arrows on it, okay? But then if I said graph it from like -2 less than x less than +4, okay, then I would put solid or actually open dots on the end of it, okay? So that's what it's telling you. You need to remember that when you have less than signs, they're open circles. When you have less than or equal to signs, they're closed circles. But either way, if they give you these limits to your domain, that means that there's dots on the end or open circles on the end, no arrows. You put an arrow on it, it's a mandatory deduction. And again, if they don't give you any of this stuff and you forget to put the arrows on it, that could also be a deduction. That one's generally may not be mandatory, but sometimes they'll have it right in the rubric that says, hey, if they don't have their arrows on it, then you got to take a point off. Okay? And once again, you have your positive infinity or negative infinity. If they don't give you any parameters like up here, well, that's what's going on there. All right? And then if you have a mix, okay, and we're going to study this in our next unit, believe it or not, where we have something called piecewise functions, and we have a bunch of things that come together. We're going to have closed circles and open circles. And remember, it's a function just so long as there's not a closed circle on top of a closed circle. Anyway, that's what's going on there. All right, and if we go to the next page, I'm pretty sure I filled this in on my typing. This is what we got going on here. If it's not there for you, well, I'll just go through it anyway. All right, so we have a quadratic function. It's a function that can be written in the form of y equals, and once again, f of x equals ax squared plus bx plus c, where a does not equal 0, because if a equals 0, it would be a line. It would basically like canceling that out, and there it is, mx plus b type of thing. So that makes that into a line. That's why they asked that. Just a silly question, but that's sometimes what they say. How come? Well, that's why. And that is called the standard form of a quadratic equation. Once again, whenever you go to do things, make sure you're in standard form, because it'll give you clues on things when you're trying to find that -b/2a. If it was out of order, you may pick up the wrong numbers. Okay, the graph of a quadratic function is called a parabola. No, I don't make these words up. That's really what it's called. It's a parabola. And it's called a conic section, okay? That just means if you took like your standard waffle cone, okay, the ones that look like this with a boom, boom, and you sliced it right there, that would be a parabola, okay? You could also get a circle, you could get an oval, there's all kinds of things you can get out of it, but this conic section is a parabola, okay? And on a parabola, you do have an axis of symmetry. That's what I was talking about on the previous page. That's the line that goes down the middle that divides it into two matching halves. So it has to be directly down the middle, otherwise they don't match. Okay, so if we folded our paper, whenever you do a parabola, they would match right up there, which makes it easier when you go to graph it. All right, and the formula for that is -b/2a, and it is a vertical line. Okay, now on that vertical line, the vertex, which is the low point or the high point of the parabola, and sometimes they refer to it as a turning point. Turning point, vertex, interchangeable. Now that vertex or turning point is called a minimum when it's a smiley. Okay, so boom, there it is right there. And it's called a maximum when it's a frowny. So if you had that going this way, there it would be right there. Okay. And the last thing you need to know is the zeros or the roots. Okay, zeros or roots are where the quadratic equation crosses the x-axis. Okay, remember the x-axis is the horizontal axis, and that means that y equals 0, which is just opposite what you think. The x-axis equation is y equals 0. The y-axis is x equals 0. Now, the other thing about the y-axis, when you're looking for that y-intercept is always equal to c. Okay, so our ax squared plus bx plus c from up here, that right there is the y-intercept. So you can always pick out a point and graph it from that. All right, so let's take a look at my pictures down at the bottom. All right, and let's just talk about them a little bit. All right, so we have a couple of examples here. This one, it tells me that a is less than 0. That's why it's a frowny. Okay, this has a maximum for a vertex. Here's my axis of symmetry, and once again, the equation for that is negative b over 2a. Here are my roots. It's where it crosses the x-axis. Okay, and I have the same thing. Oh, and there's my c. Remember I just said that c is where it crosses the y-axis. I've noted my c there. Okay, and if I put a horizontal line, this would also have a value of c right there. Okay, once you can flip it back and forth. All right, so where are we going? We go to the other side, same thing. We have a smiley. All right, not a very technical term, but covers what we need to do. That gives us a minimum, and that's also on the vertex or the turning point. The a here is greater than 0. Got my y-intercept at c, and I have my 2 roots. Okay, and the roots are the same distance from that axis of symmetry. Like if this was a distance of, I don't know, z from here to here, then this would also have a distance of z. Okay, that's one of the things you'd have to pay attention to when you're going to graph these. You want those things to match up from one side of the axis to the other side of the axis of symmetry. Okay, so that's that. Once again, stop and start if I didn't fill in the blanks. I think I did, but it would be a good idea to copy this information in. All right, so you have another point of reference for it. And when you write things, you remember more. So that's why we want to write and not just watch the videos. Okay, and I'm going to slide this off to the side. And if you decide to do delta math, by the way, that's not a bad idea. But when you go to do delta math, make sure you follow their instructions very carefully, because they were pretty technical about that. And when I started, I practiced a couple of problems, and I kept on getting them wrong because I didn't click enough buttons when I did it. All right, so I didn't pick enough points. They wanted me to graph the roots, and I graphed 5 points like they asked, but I didn't graph the roots, and they dinged me for it and didn't give me a correct answer. Okay, so I'm on page 7. All right, I'm going to do, I think, the first 11 pages on this, so you're going to see some information on it. And on page 7, we have our basic y equals x squared right here. Okay, but you remember it's supposed to be y equals ax squared plus bx plus c. Well, I don't have any of that other stuff here. That just means that b is equal to 0 and c is equal to 0. All right, and so all I got is an x squared there, and then I have a 1, a 0, and a 0. Okay, now technically I should have these two things in back reversed, because really you get the axis of symmetry before you get the vertex. You plug into the negative b over 2a, and that'll give you the x coordinate, and take that number and plug it in to get the vertex. So watch what I do here. Remember, it's x equals negative b over 2a. This one's kind of boring. First couple of them are going to be kind of boring like this. And that equals negative 0 over 2 times 1, which is just 0. All right, so that my vertex, the vertex is a point, my x coordinate is going to be 0. Now you're going to be surprised by this, but when I substitute in 0 here, I'm going to get 0 out. So you're going to do f of 0 is equal to 0 squared, which is equal to 0. Do I expect to see that on your paper? No, I'm just showing you where I'm getting information from. Once again, a little bit of overkill. So I start with this one at 0, 0. Now, this one is kind of called a parent function, okay? That means it's the simplest form of a quadratic equation you can have. There's no pluses, no minuses, no crazy stuff going on. So you can kind of use this as your basis for everything else, okay? Now, the roots for this one, and the roots, when you do them, don't go in parentheses, they go in the squirrely brackets. Everybody's favorite thing to draw. Bada bing, bada boom, bada bing, bada boom. It's where it touches the x-axis, and that's all this one's going to do is right there at 0. I'm going to put a 0 in. Okay? Now down here, I have a table of values, and it's got 7 spaces on it. It's really nice if you can get 7 points. You want to get a minimum of 5 points. And one of those points should be that vertex. Okay, so I'm going to go to the middle of my table. I'm going to put 0 here and 0 there, because that's what it is. And I'm going to go backwards and forwards. So I'm going to go -1, -2, -3, and then I'm going to do 1, 2, 3. Okay? Now, if you think about it, now it's always easy to do this with the positive numbers. Boy, that was a tough word to come up with. But if you do it with the positive numbers, you don't have to worry about the calculator freaking out on you. All right? And it's got symmetry, so when we do this, this point right here is going to match up with that point right there. This one's going to match up with this one. And this one's going to match up with that one. That's what it means when you have an axis of symmetry. So for f of 1, that's equal to 1 squared. If you square 1, you get 1. So you get a 1 here, you get a 1 here, and you go over here and you can graph these 2 points. So you go out 1 and up 1, out 1 and up 1, because 1 squared is 1. So if you're at the vertex and you go out 1, you should go up 1 whenever your a is equal to 1. All right. So then we're going to do f of 2. That's equal to 2 squared, which is equal to 4. Means I got a 4 here, and a 4 here. And then I go out 2, and I go up 1, 2, 3, 4. I go out 2, and I go up 1, 2, 3, 4. Once again, these two match. If I got this point, I know it's 2 units away. I go this point. It should be the right thing. All right? And then the last one, I know somebody's out there going, wait a minute, I put it in my calculator, and I did -2 squared, and I got -4. And that's not true. Because most calculators, they do the squaring first, and then they do the negation. What you want to do when you do this, whenever you're squaring a negative, is put it inside the parentheses with the squared on the outside, and that will give you the +4, which is smiley. All right, so be careful about that. So now I'm going to put in my 3, so I have f of 3. 3 squared is equal to 9. I got a 9 here and a 9 here, and I go out here and I go up 4, 5, 6, 7, 8, 9. I put a dot, match it up over on this side. Okay. When you graph this, it is a U shape, not a V shape. Okay. Be careful about that. If you connected this with all straight lines, like put a ruler on it, that would be wrong. And even sometimes it's going to get a little bit steep, you don't want to make it to the bottom a V shape. You want to be U shaped, nice smooth curve. And hopefully I won't mess this up too bad, because I'm doing pen, and yeah, you should use a pencil, but you might be able to see it. Ta-da! Now, should I put some arrows on this? All right, well, that's why we talked about it on the previous page. This right here says no arrows. And I stop here, and I stop there, because this is at -3, and this is at +3, so that's my whole picture, okay? So that's the no arrows thing. It also tells me where the good picture is, okay? If this told me to graph this from, I don't know, 5 to 9, well, that would move it over here, and that would tell me that my parabola is probably centered somewhere in the middle of that. That's usually what happens when they limit the domain. They give you the good picture, okay? So down the bottom, if you want to fill this in, this limits the domain. So no arrows, and it limits the range. Okay, so since we're going there, what is the range? Okay, remember range is y values. Okay, so if we're going to state our range on this particular function, all right, we're going to have a squirrely bracket. We're going to have a y such that, I'm going to put a y in the middle. My lowest value for y is right here. at 0, 0. That's going to be a 0. And my highest value for y is up here at 9. We see it there. So 9. And since all those dots are solid, you got one of these, one of these. Okay? So that's what that should look like if they ask you what the range for this. The domain is from -3 to +3, and the range is from 0 to 9. Okay? All right, so that's our parent function. That's the first one that we have to do. All right? And let's take a look and see what the next page does. All right? But flip it over, page 8. And this time I have x squared minus 6. What do you think that minus 6 is going to do? I think it's going to move it up, down, left, right, upside down. All right. Now, if you had this and put it in your calculator, by the way, I do have the other one in my calculator. You see this? This is from the previous page. I should have put that up for you. I'm sorry. All right. But once again, type it in, go to your table, get your points. Keeps you straightforward on that. You should use the calculator whenever possible if you got one. Once again, it gives you some good right answers. So let's think about what you think this might do. All right. So first of all, let's identify our a, b, and c. All right. So I do have a 1x squared there, so I'm going to put a 1. Now the b is supposed to be attached to an x. This doesn't have an x on it, which means my b is 0 still. And my c is going to be -6. So now I plug in my negative b over 2a, so that's going to be -0. And I'm saying -0. We know 0 doesn't have a sign, but I'm putting the negative there because it's part of the formula. And I divide that by 2 times 1. That just gives me 0. So my x coordinate is going to be 0. So it's not going to move it left or right because my low point is going to be somewhere in the middle. And then if you plug in 0, so you're going to do f of 0 equals 0 squared minus 6. That equals -6. So my vertex is going to be at 0, -6. -3, -6. Make sure you count that accurately. You can put this at -5 or -7 and you're done. Okay? And then we're going to go to do our graph. So we're going to start here with the graph 0, -6, -1, -2, -3, and then I'm going to do 1, 2, 3. And once again, I'm going to plug into this formula here rather than the other formula and see what happens with that. All right. But I'm going to do a cheat if you don't mind. All right. Here's my cheat. I remember from this one, the first one that we just did, that it was out 1 and up 1, out 2 and up 4. So I'm going to do that same thing over here and fill in my table. So if I go up 1 from -6, that gives me a -5. If I go out 4 from -6, it gives me a -2. If I go out 9 from -6, that's going to give me a +3. So I got my points to graph. All right, and I'm going to graph those points. Boom, 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 boom. It's really easy to mess this up and make it a straight line up. What you don't want to do, and I'll show you that in just a second, things that you don't want to do. And I'm going to draw my graph. Once again, a U-shaped graph. I missed the point by a little bit. That's not going to get me. And come back up. Okay. So there we go. And I look up on top. Hey, look at that. They limited the domain again. So no arrows. Okay, I almost missed that. Put some arrows on there. And I'm looking for the roots. Okay, and the roots are here and here. And you might say, well, that looks like, oh, I don't know, 2.5, Mr. Douglas. Well, you'd be close. But close really doesn't count around here, does it? We want to have a good number there. And it tells us to round it to the nearest hundredth. That's kind of a hint. Hey, this isn't a nice number. In fact, it even says, not nice. All right, so how are we going to figure that out? Well, I'm going to show you how to do it with a calculator, and I'm going to show you first how to do it with your equation. All right, so we said that the roots are where y equals 0, right? So I'm going to put a 0 in there. So I have 0 equals x squared minus 6. Okay, well, how do I solve that? Well, it kind of looks like a dots problem, but 6 isn't a perfect square, is it? So we're going to move the 6 to the other side, just like if we had like a 2x minus 6 equals 0, we'd move the 6 over. I'm going to add 6. So now I have 6 is equal to x squared. All right, well, that's great. I don't want to know what x squared is. I want to know what x is. How do I get rid of a squared? What's the opposite of squaring a number? Well, if you look at your calculator, and hopefully this will focus on the calculator, right? Hey, look at that. All right, and you look at the squared button. Opposite that is the square root button. So that's what we're going to do there. Kind of hard to see, but got a calculator in front of me. Most square root buttons are opposite their squared buttons. So I'm going to take a square root and a square root. Okay, so now you're going to get x is equal to, now when you do a square root, it can be positive or negative. Remember how we did this? And we said that negative 3 squared was positive 9 and positive 3 squared was positive 9. Well, same thing here. So you have to do plus or minus. It's going to be super important in this unit that you remember plus and minus on this when you do your square roots. 6. All right. So now you're saying, well, geez, that's great, but it says to round it to the nearest hundredth. Well, now you can put it in your calculator and see what your calculator says about that. And hopefully we'll get some good information here. And control equals 6. All right, hopefully you'll be able to see that. I know that it's not easy. When that says 2.4494897, blah, 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 blah. All right, we don't need the blah, blah, blah. We just need to round it to 2 decimal places. This is going to be equal to plus or minus 2.45. So I don't want to do that every time. It's not really a nice number. Well, you can use your calculator to figure that out. And if you look at it, where did it go? There it is. Okay. So once again, you can see on this one that, well, first of all, you can see that the root is between 2 and 3 because it goes from negative to positive. That's an important thing to do. All right. And if they didn't give you any more information, you said approximately 2.5, that would be to the nearest tenth. That would be pretty good. All right. But what I did, see this here? It says negative 2.45, like we found out. Okay. And what you do for that is you hit your menu button and then you analyze your graph. And then the first choice is your 0. So it's menu, 6, and then 1, and that gives you that dotted line up and down, and then you click it, drag it, and click it again, and it'll give you those numbers. Okay, that's to find the zeros. All right, so that's the second one, and we got that there, and the minus 6 translated it down 6 units. Remember, that's a type of transformation. A translation, and negative brings it down, positive would bring it up. This was a plus 6, it would move it up above the axis 6 units. All right, and we're going to try and figure out how we're going to move things left or right. We'll see that shortly. That's 2 down. So far we have done the parent function, and we've done a translation of down 6 units. Both times we had limited domains, and I didn't write my roots in, did I? So when you're doing your roots, once again, it's a squirrely bracket, and negative 2.45, comma, 2.45. Okay, where you can do that plus or minus the square root of 6. Okay. All right, so that is that. Sliding on over. All right, so now we're going to crazy land. Now we got all kinds of numbers. Look at that. Well, first of all, first thing I see, look at that. They changed our picture. So getting over negative 3 to positive 3, going from negative 1 to positive 5. So from here out to 1, 2, 3, 4, 5. So I still have no arrows. But this tells me that my window is shifting. Okay? And this time I have an a is equal to 1, and my b is equal to -4, and my c is equal to 3. All right, so one thing I can pull off of this, I know it's going to go through the point 0, 3, because remember, this is our y-intercept. And sometimes that won't be helpful. If you have like a -21 there, well, you don't have a -21 over here, but I can graph this. So I'm going to go 1, 2, 3, and I'm going to put a dot. I know that that's going to be a dot there. All right, now I want to find my vertex. So for my vertex, I'm going to do my -b. First, I've got to find the axis of symmetry. I'm going to do my -b over 2a. And that's going to give me a -4 over 2 times 1. And that's going to give me a +4 divided by 2, so that's going to be a 2. So x equals 2 is my axis of symmetry. Now when you're drawing in an axis of symmetry, put it in as a dotted line. Just like I just put my domain parameters here just to remind myself. This is at x equals -1, x equals 5. Well, now I have this axis of symmetry at x equals 2. You put it in as a dotted line because it really isn't part of the graph. It's just kind of a signal point for you. Hey, this is the middle. Okay? If I fold my paper at x equals 2, things will match up wonderfully. All right? Now, once again, I'm doing this without a calculator. So I want to plug in 2 into this equation. So I'm going to have f of 2 equals 2 squared, not to the 4th power, Douglas, minus 4 times 2 plus 3. And you should have some sort of calculator around to do that, but this isn't too bad. This is 4 minus 8 plus 3, and that equals -1. So at 2, I'm at -1. So 2, -1. There's my vertex right there. Okay. So going out from there, and I should put that up here, 2, -1. And I'm going to go to 1, 0, -1 going up, and then 3, 4, 5 going down. Now, you could do what I did here and get all 9 of my, or all 7 of my points over here. But once again, we've kind of talked about it a couple of times. If you remember, you go out 1 and 1 squared is 1. So if you go out 1, you go up 1. Okay, and if you do that, that's going to give you -1 plus 1. It gives you 0. So that's going to be a 0 here and a 0 here. And we said that we have this point right here at 3. So that's 2 units away. So on the other side, I should have one right there. So that gives me a 3 and a 3. And then my last point is going to be out 3 and up 9. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. And then the other side of the axis of symmetry there. Once again, usually looks the same. When your a is equal to 1, you should be in good shape doing this. Coming down, round the bottom, up to the top. Limited domain, so no arrows. And I got to fill in these numbers, which look like they're going to be 8 and 8. Okay. And what did we find out here? Ah, the roots. Roots are where x equals 0. Or I'm sorry, y equals 0. So they're 1 and 3. 1, 3. Once again, squirrely brackets, not parentheses. It's not a point. It's just the x values. If you wrote this as 1, 0 and 3, 0, that's technically wrong. And the reason it's technically wrong because the roots are just the x values. Okay, really important you follow the instructions on that. That's one of the things they ask a lot of times for function rules and things like that. All right, if they ask you just for what the x value is, give them just the x value. If they ask you for a root or the input when f of x equals something, just give them that input. Don't give them the output as well. All right. So as far as what did the -4x do? Well, that's what moved it 2 units to the right. And the reason it's only 2 units and not 4 units is because of that divided by 2 up here on the axis of symmetry. And the +3, I already talked about that, is your y-intercept. Okay, and it says, did you notice that the window changed? If they give you this information, they're helping you find the center of your picture. Pay attention to that. If they don't give you that, well, that's okay too. You just gotta figure it out for yourself by using the formula. Okay, the negative b over 2a, that gives you your middle, and you just work out from your middle. Okay, so we're going over to page 10. Do I have the graph of this one? I think I did. Is there anything I noted on that? Hey, there it is. No, actually I did notice something on this. When I put this one on my calculator, once again, I went and I found that low point. There's my vertex, okay, from my table. Here's my roots, okay, 0, so root and root. Now notice I have that 2, 1 on there. In order to get that 2, 1 on there, I hit Menu, and then I did Analyze Graph, and then I think that it was number 3, and it was minimum. And when you do the minimum, you have to go past, you have to start from one side and go all the way past the lowest point. Like if I just did from here over, it would tell me right there. And that's not what I want. I want it at the bottom, not where it's called the minimum, not the relative minimum. Okay? And, okay, so that's that. Let's see what else we got here. Flip over to page 10. Okay, and on page 10, looks kind of similar to the second one we did with the x squared minus 6, only this time we got 2 things going on. We have a negative there, and then we have a plus there. So it still means I don't have any x term, so that means I have a -1 here, 0, and 4. Oh, I know what I forgot to check off last time. Was this a minimum or a maximum? And since it's a smiley, whenever you have a smiley, it makes it a minimum. Okay? Really important to answer all the questions. I'm glad I caught that and went back to it. So this one we're going to find out. Okay? This negative here, this is going to make it a frowny. So that's going to make this a maximum. And since there's 0 in the x, I know that my axis of symmetry is going to be x equals 0. Okay, and I know that my vertex, when I plug in 0 there, is going to be f of 0 equals 0 squared negative 0 squared plus 4, which is just 4. And let's see, we can plug in some numbers for this. So I'm going to do 0, 4 in the middle. All right, and I'm just going to do f of 1, f of 2, and f of 3 to get the rest of my points. That gives me -1 squared. See how I put the negative on the outside this time instead of the inside with my parentheses? Really important, because we want to square the 1 and then negate it, and then add 4. That's going to give me a 3. -1, -2, -3, 1, 2, 3. That makes this a 3, and this a 3. Do the same thing, -2, parenthesis, squared, plus 4. 2 squared is 4, -4 plus 4 equals 0. 0 and 0. And then -3 squared plus 4 equals, 3 squared is 9, so -9 plus 4 equals -5. -5, -5. So now I can graph this and we'll get a good picture of this. Oh, can anybody tell me what the roots are? Come on. When y equals 0, these are our roots. So squirrely bracket, -2, 2. Okay. And when we go to graph this, we start at 0, 4. We go out 1 and we go down 1. 1, 3, negative 1, 3. We go out 2. We go down 4 from the vertex, which just leaves us at 0 and 0. I go out 3 and down negative 5. Negative 5. And I draw my thing round the bottom. And were there any limits to my domain here? Okay, so there's no limits. Which means I put an arrow and I put an arrow. Okay, don't forget that. And what did the negative do? It flipped the graph. Made it a frown. Okay, and I'm pretty sure my remember too. Did you remember the arrows? And we did. And while I'm thinking about it, what is the range? Okay. The domain is all real numbers. Okay, because you can put in any number you want, you got those arrows going on. But the range is limited because it doesn't go any higher than right there. Okay, so if you're doing this, put your y in the middle, and it's got to be less than or equal to 4. And then this way you do one of these with an infinity, but the infinity has to have a negative on it. Or if you did this in set builder notation, this is set builder notation. If you did it in interval notation, you have a rounded bracket, and then a negative infinity, comma, 4, square bracket. Okay? And actually this one, you could skip this part and just leave it as y is less than or equal to 4. That would also be okay. So y less than or equal to 4 is okay too. All right. I think I got one more I want to show you. I know it's a little bit longer than the last one, but being careful with my graphing and making sure that you get the idea. Accurate graphing is super important. I don't want to see any like little Nike swooshes going on here like we had with the exponential functions. It's got to be accurate. Accuracy counts. Okay. So page 11, what did we do? Oh, I think I'll do page 11 on the calculator, and hopefully you'll be able to see it. I don't think I printed that one out. And then I have you guys, I think the homework pages out of this are 12 through 15. And there's a couple of surprises on that, but nothing in particular. It's like 4 or 5. And if you do the delta math, I think there's 10 that you got to graph. And we'll come back and talk about it next time. All right, so let me do this one real quick. If I had my calculator, this is what I would do. I'd turn it on. What a great idea. And hit enter. Well, that shows up pretty well on the screen. And I want to get a new thing. And once again, you don't want to use Scratchpad. Not much you using Scratchpad before we went on break. I'm going to kill you because it's not as accurate. Once again, y and f of x are the same thing. I do my x squared minus 4x, not negative 4x, minus 5, not negative 5. Hit enter. I get a smiley. Look at that, it kind of goes off the screen. If I wanted to, I could change that. I don't think it's necessary. I remember to show you, I'll show you how to do that just so in case you weren't sure. And I don't know how far it goes down, but I'm just gonna double click on it and delete it. And I'm gonna go, I don't know, negative 10. Hey, look at that, we got it. So I can see all the good points here. I got my vertex down at the bottom. I got my roots. And I could use my calculator to find that. Let me show you that real quick. I got a menu. And I go to 6. And to get my zeros, I hit 1. And I click. And I drag. And I click. And then I do menu. And I do 6. I do 0. And I click. And I drag. And I click. So I got my 2 roots. Negative 1 and 5. And then I can also find my vertex, menu, 6. And since this is a smiley, I'm going to use the minimum, so that's a number 2. I think I said number 3 before, but that is number 2. And I click and I drag past the bottom. And look at that. There it is, 2, -9. All right, so I have basically the key points that I need. I know that I have a -5 on my graph. So let's see what I can get out of this without even going to my table. All right, so here we go. I know that it goes, so here's my origin. It goes through -1, 0, and it goes through 1, 2, 3, 4, 5. Yeah, I gotta work on getting these darker, don't I? All right, it goes through 2, -9, which is down here. It goes through 0, -5, which is here. And if it does that, that means it goes through this point as well. All right, so, because remember the axis of symmetry right here, down the middle goes through the vertex, so that's x equals 2. And just for a little cheat, remember that 1 squared is 1, so 1 here and 1 there. And, ooh, -2 to 6. So that means I got to go one more point up here, and I could use my table for that. So why don't we just pull up our table real quick, and you can verify my other points. So Control T, and I need to get a point that matches up with -2, which is 6. That goes to 7, 3, 6, 7. So since this was bigger than usual, I have to get the bigger than usual over here, which gets me over to this one. Once again, oh, and there's a common error that happens a lot with these. Don't be that guy that gets to this point and then just goes straight up. That would be bad. Okay, that'll cost you. All right, sometimes it gets pretty steep, but make sure you go out a little bit. All right, so this is no. And we have our vertex is at, well, let's fill in all these things, guys. It's asking for the ABC, so 1, -4, -5. It is a minimum. Our axis of symmetry is x equals, I'll put the work there for you, -4 divided by 2 times 1, which is going to give me a 2. My roots are at -1 and 5. And table of values, you should have that 2, -9 in the middle, and then 1, 0, -1, so 0, -5, -8, -8, -5, and 0. 3, 4, 5, smiley face. Okay. So you got some practice to do. Once again, if you have a calculator, it will make your life easier, but you can do it without a calculator. Just need to be careful with these things. And give yourself a little bit of time to get some practice done. Once again, there is a delta assignment, or you can work your way through pages 12, 13, 14, and 15. Now 14, you're just answering questions about what the graph looks like, getting the axis and those sort of things. So that's a little bit easier. And 15, you're just identifying some of the points. That's the way they're going to ask some of the questions on it. All right, so good luck with that. And the next class, we're going to be talking more about roots. Roots are important. So thanks for your attention. And I'm sorry if I was a little long-winded, guys. Have a great day.